So this is Geometry Semester 2. It's the 5th unit, Circle, Angles, Arcs. And it's the first lesson, Arcs by Radius Practice. It's on creatormath.com or creatormath.weebly.com under the Geometry tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Right, and maybe if I can just show you that on my phone, I'll pull up the website too. Right, so if I typed creatormath.weebly.com and then it pops up for me here, I'm going to click on this one. Just real quick, if you were looking for when is the comp book due, you're going to find the picture of the comp book on the home page, and you're going to scroll down and see the different, if you're watching this video later, these might be different dates obviously, but find second week. We're in the 5th week right now, so just find that date and find the number of pages that are due for the composition book turn-in. Then when you're thinking, where are those notes, right, go to the Geometry tab. Scroll down to the unit we're in. So this is Circle, Angles, and Arcs. This is the first lesson, Arcs by Radius, page 93-94, where the notes go. And if you click Notes right here, this is what pops up, what you put onto those pages in your comp book. All right, so you'll expand them so you can see them clear. Copy these in, and then as I'm doing the problems, these are the things, of course, I'm referencing back to when I'm trying to go through. I'm not doing all the notes when I do the problems. I'm just, solving the problems, but sometimes talking about there's a lot more stuff in the notes that go in your comp book first, and then these problems go in after, and you solve these. Right? Hope that helps a little. So this one says, given the arc ABC, what's the measure of the angle in degrees? So here's an arc ABC. Here's A. All right. And here's this thing here, which forms an angle, A, B, C. So they're talking about this segment, and the arc running between it. Some things to note. This is called a minor arc. This one on the other side, because there's always another one created when we say ABC, if we're talking about the minor arc here, there's another larger one created. This is going to be the major arc. And again, this is in the notes and a lot more information beyond that. There's a central angle here, and then there's an arc angle. So central angles here, arc angles around the outside of or on the actual circle. Radius versus diameter, there's a radius that goes from the center to the side. That's radius. And then the radius, R-A-D-I-U-S, and then the segment that goes from circle to circle through the center, that you should remember is called the diameter. And we'll use that on a little bit later problems here. So given the measure, what is the angle in degrees? We don't have any information. We're literally eyeballing this, but if we have anything that goes through a quarter of a circle, we know that a quarter of a circle, this angle must be 90, and therefore the arc angle is 90 degrees. And what you're keying on is the definition that a circle has, right? If I start here and go all the way around, has 360 degrees. So this is 90, 180, 270, 360. So they're going to tell us some other ones, and we're just going to use our understanding of the number of degrees in a circle to find those. So 90 degrees. Given the arc ABC, so now we've got A, B, and C. Notice it's going all the way around here. There's a central angle and an arc angle. They're equal when we're talking about in this context. So ABC, what's the measure of the angle in degrees? This one here goes all the way around. It's 180 degrees. Notice also this is where a straight line comes from. There's an angle called a straight line, and the number of degrees in a straight line is 180 degrees. Same thing. So all these things sort of play together and play off each other. And once you know one definition, you should be able to translate it into understanding the other definitions. Given the major arc, so look at what they did for us. They said major. So when we start at A, B, C, we're now going here to here. But we're not looking at this. This would be the minor arc because it's smaller. Minor meaning smaller, and major meaning larger. So they want to know the measure of this one, right? Well, we went 90, 180, 270. That's all they're asking us to do, is sort of orient our thinking in terms of the degrees of a circle, in terms of the central angle or interior angle, and then the arc angle around the outside of the circle. And they are the same in this context. Given the arc ABC, so now we have an ABC here, right? How much is this? They didn't tell us anything about this measure. They didn't give us any facts. So we are looking at this like the drawing is drawn to scale. So remember, if we were to put a line right down the middle of this angle, since this is 90 degrees, if we did one down the middle, that'd be 45, half, right? This one's up higher. So they're keying us in on the idea that there are some important angles around the circle. We love the 30 degree, so this is a 30 degree. And if you come down here and go 30 degree up this way, 30 degrees, right? Then this one in the middle would be 30 degrees, because if the whole thing's 90, 30, 60, 90. So we love 30, 60, 90 all the way around the circle. Here, approximately. And of course, I'm just eyeballing it, right? The other measures we love are this 45. There's a 45 here, 45 here. So there's a 45 here. So your brain is needing to sort of translate the 360 degrees of a circle into now an interior angle here, or central angle. And that is the same measurement of the angle along the arc. And now the arc is this actual portion of the circle that is in question. So 30 degrees. How can the length of an arc be calculated if we have a radius and a radius angle? So we're going to do a couple problems with this formula. The formula is right here. It's an interesting idea. What they're asking for is length. If we started here and traveled around the circle, this would be circumference. Circumference is the distance around a circle. The other word you know is perimeter. So say you had a square, we would say if we start here and go around the square, the distance around the shape, or as I travel on each piece of the shape and come back to where I started, that's called the perimeter. On a circle, perimeter is called circumference. But it's still perimeter. So you could say, what's the perimeter of a circle? We want to say circumference because we change the word when we're talking about a circle. What we do is take a ratio here, the radius of the angle, okay? And I'm not sure I like the way that's worded. It's the portion, the arc angle that we're talking about, over 360. So let's say you were this far and you went here. You would take this amount divided by the whole amount. That would give us a portion of the whole amount times the circumference is the distance all the way around, and that'd tell us the distance here. And that's kind of a quick explanation of why this formula is what it is. All right, let's try an actual problem. Given the following figure, what is the arc length of minor arc AC? So here we are. Now we're traveling this way. A starts here, goes to C. It's the minor arc, so they don't mean the one over here. They mean the one here. We know we could find the whole distance by doing circumference. Circumference is 2 pi r. And we want just this percentage. So notice it's 30 degrees. So we're going to take 30 degrees of what we have, divide it by the whole thing of 360, and come up with a ratio that we can multiply by the length of the whole thing to get the length of this piece right here. So let's see what else we got. Angle divided by 360 we've got. Circumference, which is 2 pi r, we have here. We're going to say equals. We're going to rewrite this and fill in everything else. Notice the units are canceling here with each other. We have a 2, we have a pi, and we have a radius. Here we go. There's the radius. R equals 5 centimeters. So 5 centimeters. We'll keep the units in there also. Go to your regular calculator. Don't forget to turn your calculator sideways and undo the lock, the scroll lock, so that, or the rotate lock, so that we can unlock it. The reason you need to rotate it is because we need the pi button right here. So we're going to have 30 degrees divided by 60 degrees. 30 divided by 60 times 2 times pi. We're going to drop in the very symbol. Look at that, drops it right in, times 5. And we get 15 point 30 divided by 60 times 2 times 5. I get 15.71 for this, approximately equal. Unless I'm typing it in wrong. Am I in radians? No, I'm in degrees. That's good. Doesn't matter anyway because they cancel. Times 5. So I don't like this one immediately, but I'm going to go with 15.71, and I'm going to check to make sure that this is corrected when you take it in your assignment. Okay. So here's another arc length. In this case, they're telling us the actual length of the arc first. They're saying this is 5 feet. And now they're asking us what's the radius. So we're going to go back and say what's the measure of our angle, what's the arc angle, divided by 360, times 2 pi r. And in this case, we have an amount that it's equal to. This is going to be arc length, right? And they're telling us this formula right here and here. So we've got a 30-degree angle, so we've got 30 over 360, 2 pi, and we have r. That's our left in question, so let's leave that as a variable, equals arc length of 5 feet. Right? So we need to solve this for r. Let's do a lot of equation solving here. Since this is on the bottom, the 360, let's multiply both sides by 360. Let's divide both sides by 30. So 30, 360 gone. Let's divide both sides by 2. Gone. Let's divide both sides by pi. Gone. Here. So I think r is approximately equal to, I'm going to take 5 times, see in here, rotate the right direction. There we go. Clear this out. I'm going to take 5 times 360 divided by 30 divided by 2 divided by pi. And I get 9.55. Round this up, 9.5. See the 4 right there? Because the number to the right of it is 5 or higher. You round this 4 to a 5 and truncate everything else, which means cut it off. 9.55, and I like this a lot better. If you can barely see this in the bottom of the screen, that one looks like it's right. So I'll go back and check the other one, all right? So this is on creatormath.weebly.com. Follow the lesson names very carefully on the table of contents. Make sure you're in Geometry tab, Semester 2, 05, Circle, Angles, Arcs, and it's Lesson 1, Arcs by Radius practice.